ARP Productions present Drawing Math, the Isaac Newton edition. Newton was born in 1642 in Woolsthorpe, England. He was born in a farming family, but never wanted to stay a farmer. So, with the help of his uncle, who was a professor, he went on to attend Trinity's College in Cambridge. He loved the basic sciences, but he always wanted to study more advanced topics. He studied optics, mechanics, and alchemy, or chemistry. He had many notable achievements, like discovering the laws of gravity, but his mathematical achievements were almost underrated. While his greatest contribution to calculus was based off of differentiation and integration, his terms and methods are not used today. He called differentiation the method of fluxions. The fluxions are the instantaneous rate of change of a point on a curve, and the fluents are the x and y values. It could be defined as, if y is a function of t, then the derivative of y with respect to t is y with a dot over it. This is called dot notation, which is the notation he used to define terms. His dot notation is the equivalent of what we use today, which is y prime. Here is an example of how he would set up and solve a derivative problem. Problem being 5x squared plus 2 divided by 7. His first step would involve setting it equal to 0 and solving for that. His second step would be to plug x plus x notation O in for x and y plus y notation O in for y. The x notation is the rate of change, and the O is the equivalent of a small amount of time that goes by. His third step would be to subtract the original equation from the second equation. The fourth step would be to divide out O, the small amount of time. And the fifth step would be to remove any terms connected with any remaining O's because they are no longer needed. He also worked on the inverse method of fluxions, or integration. This is about finding the area that is under a curve and bound by an axis. According to Newton's work, the area beneath the curve can be determined simply by using algebra and approximating. To approximate, the area of individual rectangles underneath the curve can be added together to find the whole area. The graph could also be drawn like this to find the area between A and B underneath the curve. Newton's notation would appear as a y with a line over it, which is equivalent to what is used today. Here it is again, according to this graph, with a and b on either side of the summa, with f of x and dx. Thank you for watching.